Okay, this is part 4, AP Calculus, definition of derivatives. Last thing we did, I think so, number 3. Number 4 is exactly the same, but instead of 2x squared, 5x squared. Number 5, the same. Number 6, the same. 7. Let's do number 8. Let's do number 8. They are all the same, right? You can try, and if you have any question, you can send me an email, and I will solve any problem you want. Let's do number 8. Number 8 is 2x cubed, where at x equal minus 3. Again, 2x cubed at x equal minus 3. This is number 8. Number 8 is f of x equal 2x cubed at x equal minus 3. This is cubic function. Let's find its derivative. Okay, we can find the derivative directly. F prime of x equal 3 multiplied with 2, it's 6. X to the power 2 multiplied with the derivative of x, which is 1, so it's 6x squared. He needs us to find the derivative at minus 3. So the answer should be 6 into minus 3 to the power 2. That is 9 times 6, 54. By definition, the derivative at a certain point, 1, its limit, as h tends to 0. Same thing that's each time. So it's f of x1 plus h minus f of x1 over h, which is equal to the limit as h tends to 0. Second step, we just substitute, is we take instead of f of x plus x1 plus h is 2. X, we replace x1 plus h cubed minus also 2. Instead of x, we replace x1, it's cubed over h, which is equal to the limit as h tends to 0 of 2. We expand x1 plus h, cube the first, plus 3 times square of the first times the second, plus 3 times the first times the square of the second, plus cube the second, minus 2x1 to the power 3 over h. What is that equals to? Limit as h tends to 0. we multiply all of them by 2. That will be x1 h squared plus 2 h cubed minus 2x1 cubed. We take it out with plus 2x1 cubed over h. Now, since we have h in the denominator, what we do is we take h common factor up. It's enough. 6x1 squared plus 6x1 h plus 2h squared, and we cancel the h. Then we replace 0. This will be 0, and this will be 0 instead of h. The final answer is only 6x1 to the power 2. And we did it here. Now, this is f prime of x1. What is f prime of minus 3? So it's 6. Instead of f of x1 minus 3 squared, the answer will be 54. Let's see if we have another thing. The same. I'll leave it for you. Number 9. It's the same. Instead of 2x cubed, it's minus 3x cubed. X power 4, number 10. X power 5, number 11. We have a lot of them. Let's do x power 5. Let's do x power 5. Okay? And this is number 11. Number 11. It's all polynomials the same, right? F of x equal x power 5. He just wants me to find the derivative. He didn't give me any points to replace. Same. If at the end, when we finish, we find we just replace instead of x the point he gave me. What is derivative? 5x to the power 5 minus 1 times the derivative of x, which is 1. So 5x power 4 is the answer. By using the definition of derivative, the derivative at x1 certain point is equal to the limit as h tends to 0 of f of x1 plus h minus f of x1 over h, which is equal limit as h tends to 0 of x1 plus h instead of x to the power 5 minus x to the power 5 over h. Here is the problem, right? We have to expand x power 5 now, and this will be a problem. What we do? What we do is this is simple to expand it by binomial theorem, right? Using binomial theorem. Now I don't know if we have that really time to do it using a binomial theorem by in this video. I don't have that much time, so I will do we will do some more videos for sure using binomial, but let me tell you what it will be. It will be x to the power 5, right, plus 5 x to the power 4 times h plus 10 x to the power 3 h squared plus again 10 x to the power 2 h cubed plus 5 again x power 1 h power 4 plus 1 h to the power 5. This is simple if we know the binomial theorem. X power 5. This will go with that over h. If we take h common, right, limit as h tends to 0, this is over h common factor. The first term will be 5x to the power 4 plus all the other terms, h will remain in them, right, because they are more than h power 2, h power 3. So here we're left with h power 2 plus 5x h to the power 3 plus h to the power 4, right? H cancel, substitute instead of h 0 makes all these terms 0, right? 0, 0. What left is only 5x to the power 4, and this is the correct derivative. This is the correct derivative, okay? Now, let's see what else we do have. If we do it in this video, if we can do something else, it's number 12 now. 2 radical x at x equal 9. Yes, I guess we can do it in this video. 2 radical x at x equal 2 radical x at x equal 9, right? Number 12. Yep. Okay, number 12 then. 2 radical x. Number 12. F of x equal 2 radical x when x equals to 9. Let me do it that fast. F prime at x1 equal limit as h tends to 0 of, let me put it directly, it's 2. Instead of radical x, it's radical x plus 1 plus h minus radical x1 over h, right? What we do here, this is 2 also, right? 2 radical x1. Let me take 2 common factor, limit as h tends to 0. Let's take 2 common factor outside, radical x1 plus h minus radical x1 over h, and we, if you remember, we multiply with the conjugate of the numerator. We rationalize the numerator by multiplying with this, and we do the same thing down in the denominator in order not to change the fraction. When we divide by the same, multiply numerator and denominator by the same number, we get the same answer left, because we're multiplying with 1. So it is simply 2, this is a minus b into a plus b, so square the first minus square the second over h into radical x1 plus h plus radical x1. This simplify with that. What left is 2h, h cancel because this is product 2 times h. So what left is, and directly let me put instead of h 0, so I left up with, sorry, without limit, it's 2 over 2 radical x1. So the answer will be 1 over radical x1. He wants it at x equal 9. So what is f prime at 9? It's 1 over radical 9. So the answer is 1 over 3. We can know it from here directly. If f of x equal to radical x, I told you what is this derivative before. F prime of x equal 2, and we do just the derivative of radical x, right? So the answer will be 2 multiplied with 1